All right. Good morning, everyone. Welcome back to Comp 3350, Software Engineering 1. I hope you've been able to keep warm. I know that you are probably working on lots of stuff with your assignments and other courses, and I know that you, hopefully got a little bit of a break after having finished iteration 0. But we're out of one fire and into the next in this course, and we're going to be spending some time talking a little bit about what the expectations are for iteration 1 today. And we're also going to be spending some time talking about version control. So based on the responses that I saw last week about how comfortable you are with version control, I'd like to spend just a tiny bit of time today looking at Android Studio and cloning a project. So cloning a project from GitLab, sorry. And then kind of just generally stepping through the terminology and the flow that you will be using with working with version control. I don't want to spend a huge amount of time doing this because it's straightforward. Using version control is straightforward. I don't want to say that it's easy to do. It's straightforward, and once you get the hang of it, you won't really need to spend a lot of time thinking about it very much, but it's worth getting a sense of what the terminology is. So let's, yeah, I did this already. Let's take a look at that. If there's time today, we'll take a look at testing as a concept as well, but I'm kind of guessing that we'll push that further into next class. But I'll give you a brief taste of this today because I'm going to show you a sample project that's been published up on the course webpage. So first things first, iteration 1 starts now. Iteration 1 starts now. Iteration 0 is due on Friday. You should expect to get feedback from me by this Friday about your iteration 0 submissions. The feedback that I give you can come in two forms. I might just comment directly on your issues. I might just put comments in the issues that you have in GitLab, and I'm usually going to do that if I think you need to change an issue. So if you have a user story that I think is too big, or if you have a feature that's not very well defined or something like that, I might just comment directly in that user story. The rest of the feedback about your vision will come in the form either of an email or in an assignment folder on Learn. I haven't decided how I want to distribute this feedback to you yet. But the big news is that you should expect to get some feedback about this by Friday, by this upcoming Friday. I want to get this back to you quickly because I want you all to be on the right path forward. And since iteration 1 is due so soon after iteration 0 is due, I want to make sure that you have an opportunity to change course if you need to change course. That said, let's take a look at iteration 0 on the course webpage. So I'm just going to zoom over here to our course webpage. And I'm going to click on project, and I'm going to click on iteration 1, and I'm going to take a look at iteration 1 description. So the basic idea with iteration 1 is that you are going to be doing some coding now. Iteration 0 was all about planning, getting a common goal for your team, getting a sense of what it is that you want to build. Iteration 1 is now going to be start building that stuff that you said you were going to build. The process that I want you to go through, and I'm going to ask you to do this. I thought about this, and I want you to actually do this. I want you to start using milestones in GitLab to manage your iterations. It's straightforward to use milestones. You just create a milestone, give it a name, and you can assign tasks to milestones. I want you to decide how you're going to be dividing work among yourselves. So one of the things that you are going to be doing when you're working on tasks with your projects is making a decision about how you're going to do the work, how you as individuals are going to do the work. There are two kind of valid ways that I would suggest you think about doing this. And whatever you decide to do now, I really strongly suggest that you switch for the next iteration in terms of how you decide to give work out to your peers. The first way is that everybody gets a story. and they do the front end all the way to the back end. They build the UI, they build the logic, they build the database stub, they build the data model. They do everything for that user story. That means that each one of the people that are on your team will be assigned a user story, and they will complete that user story in its entirety. The other way that you can do it is that you can kind of assign different people to have specialties, I'll say. You can have somebody be responsible purely for doing the data layer. So this might be something that you're interested in trying if you have somebody that has had experience in Comp 3380, for example. That specific part, the database part, is not really that big of an issue for this iteration because you're really just going to be building a stub database. You're not building a real relational database implementation yet. You're just building something that holds data temporarily. But it gives you an idea of how you could separate. So as opposed to separating based on user story, you can separate based on tier of the n-tier architecture. You have one person that's responsible just for the UI, one person that's responsible for just the data model and the application logic, one person that's just responsible for the data layer, the persistence layer, and maybe one person that's responsible for just testing. My personal opinion, this is my personal opinion, is that doing full stack, so like user story per person, is a much better way to do it. The rationale that I have for that is a little morbid. There's this idea of something called the bus factor. Has anybody heard of that before? Okay, the bus factor is what happens if somebody gets hit by a bus. And a bus factor of 1 is your project is going to fail if one person gets hit by a bus. And that the strategy of one person is responsible for testing and one person is responsible for data layer and one person is responsible for UI, it kind of means that you got a bus factor of 1 for your project. If you distribute and everybody does full stack, that means that you're going to be a little bit slower at the beginning. You will be a little bit slower at the beginning, but that's okay. That's okay. But it means that everybody's going to have the ability to do everything in your project. So then you'll have a bus factor of 5, and I hope you're all not riding on the same bus. So you're going to decide how to assign tasks to your team. I'd like you to actually assign issues in GitLab to the people who have the work. So if you're trying out I'm going to do the UI and pass it off to somebody else, then just reassign the task over and over and over again to the person that's going to be doing it next. If you're doing a user story per person, then just assign it to that person and then have that person be responsible for closing it. You're going to have to make developer tasks for your user stories for this iteration. So if you didn't do that for iteration 0, and don't stop. Don't wait for my feedback. Just keep going. Just keep going. If you haven't done developer tasks for iteration 0, start adding developer tasks. And if you already have developer tasks by the time I get to assess your user stories, that's fine. That's great. That's excellent. If you haven't done it, though, that's something that is a requirement for you to do before you get started. The implementation that I'm looking for this term, that we're looking for this iteration, is we want you to start building up some of the domain-specific model. So the data model, we want you to build the data model. We want you to build up some user interface. We want you to build some interesting logic, so the core things that your app is supposed to do. We want you to implement automated unit tests for anything that's complex in terms of its behavior. I'm going to show you an example of unit tests in the sample project that was posted, and we will talk about unit tests this week. The implementation of the database is not a relational database for this iteration. We don't want you to build a relational database for this iteration. This iteration, the work that you're going to be doing is just as something like a list or a map. So literally these types, list and map in Java. If you've used HashMap before, this is kind of what we're looking for. That's it. Your app will start, you'll do stuff with it, Stuff will be in the map. You will shut down your app and start it up, and it will just be back in the original state. That's what we're looking for this one. So there's not really any real persistence, but you're going to have a layer that's for persistence that's going to have these stub implementations. I want you to build an architecture diagram for this. So I want you to put the class names that you have created in your actual application into the appropriate place in an architecture diagram. How you decide to build your architecture diagram is up to you. I prefer you to put a file named architecture.md in your main folder to tell me what architecture is approximately, and how you visualize that is up to you. So if you want to use Mermaid, GitLab can render Mermaid diagrams built into it. That's nice. If you want to use, I don't know, PowerPoint or something and save it as a PNG, that's also fine. That's up to you and your team to decide how you want to do it. The evaluation, I'm not going to step through the rubric today, but there is a rubric that's sitting beside this document that you can check out to see how your work is going to be assessed for iteration 1. The way that we're going to be deciding what is handed in for iteration 1 is that we're going to be taking the last commit before the due date. Either the last commit before the due date or the tag that you tell us to assess for iteration 1. When you're doing a tag in GitLab, you can use command line tools to do this, or you can use Android Studio to do this. A tag is just a way to mark a specific commit with a name. GitLab will actually create this thing called a release when you have a tag, and you can upload files to the tag to release. I'd like you to build an APK for your application. So an APK is what Android devices use for their application format. I want you to build this APK, and I want you to attach it to that tag, to that release in GitLab. We're going to be targeting a homogeneous environment. Everybody's going to be using the same devices and the same emulator images for building images, for building their app, primarily because we don't want people to have, like, you know, high-end flagship phones for one team and then a really crappy old Nexus 4 for other teams, because that wouldn't be very fair. We want everybody to have the same thing. So we're giving everybody crappy old tablets. We're going to be using the Nexus 7. I need to talk to Jeff, but I'm kind of thinking that the strategy for this is that we're going to ask individual members from your team to just go see Jeff and get a tablet if you need a tablet. If you don't have an Android device, so if nobody on your team has an Android device, it would be good to get some physical hardware for you to test your work on. But the emulator, or alternatively, if your laptop is not capable of running an emulator for an Android device, it would be nice to just have a physical device so that you can try running your app on the real thing. Okay, are there any questions about iteration 1 before I step into taking a look at the sample project? Let's get coding. Yeah, let's get coding. Okay. The other document that I want to point out to you, I'm not going to read this to you, I'm going to point it out to you, is that alongside the iteration 1 is an Android development guide. This was originally written by John Braco and has been updated by me. And it basically takes you through starting up Android Studio, setting up your emulator, and then beginning to build UI classes with the UI editor in Android Studio. So if you've never done any Android development before, this would be a good document to take a look at. There's a lot of good documentation on Google's website for Android development, but this is a nice summary of all of that stuff that's available for you. Okay, so with that, I would like to step over here. So under our GitLab on code.cs, under our group here for winter 2023, There is a project that has been created that is called sample. This is linked to in the document that's describing iteration 1. So you have a quick link to this, but you can also find it because it's in the project, and you can also find it because I'm showing it to you right now. This is an Android application. This is an Android application that starts to implement srsys. So this is starting to implement the vision that was shared with you as an initial sample vision. What I am going to do here is I basically want to kind of do something that you're not really going to be doing with yours. One of you are going to do something slightly different in that you're going to have to create an initial project and then upload it to GitLab. The rest of you are going to be doing this with your project by importing it into GitLab once you have it going. Importing it into Android Studio from GitLab. So I've got Android Studio started here. I'm going to click on this button, Get from VCS, Version Control System, and I'm going to paste the URL into this. It will prompt you for a username and password. The username and password that you should enter here are the username and password that you use to sign into GitLab. Yes, it's not UMLearn, so it's something slightly different. And once you do this, it's going to start cloning your project. It's going to download the code from the remote repository and then start munching on it. I'm going to pop over here to the presentation view just so it's a little bit easier to see. Is that easy to see at the back? Is that okay? Okay. So I'm also going to show my project. So this project follows the architecture that I described in class. So there's a bunch of different packages here for the different layers of the application. There's presentation, persistence, and business. Business is that middle one, the logic tier of the application. The objects, this is the data model for the class, the data model for the project itself. So these are all the classes that are going to be used throughout the application. This is a way for us to run this on the command line. So when I got this project as a student, this is how I used it. This is how I used it, was on the command line. But then now it's going to be run using an Android app. So the Android app here, I believe it starts at the home activity. This is a good way to organize your code. I would suggest that you do something very similar to this in terms of setting up packages for your architecture. So packages for each of the different layers plus the data model package. The other thing that you can find in this that is helpful is there's a test package here. And you can start to see that there are tests for some of the objects. This is giving you an idea of how JUnit works. JUnit's the framework that we're using for testing. And then there's this file called all tests that will run all of the tests that have been set up and written in the package. Okay, so this was cloning a project. So we have a project on GitLab. We've cloned it. We've pulled it down onto our machine into Android Studio so that we can start working on it. Another thing that you're going to be doing when you're working with this is making changes to things. So I'm going to go to, I don't know, I'm going to go to the main function here, method. I'm going to add a really helpful line of code here. Android Studio is kind of nice. It highlights the lines that have changed. So this green line is saying that you've added something to the project. Once you make changes to files, you're going to want to commit the changes that you've made. Making commits with Git is a two-stage process. You add the changes that you want to commit, and then you make a commit with the changes that you've made. So when you right-click on a file or folder, there's this Git menu here, and there's a bunch of different options here. There's add. Add is what's going to do, it's called staging something for commit. So it's taking a bunch of files that you want to add. Maybe you've changed the data model and the application logic layer and the stub implementation. You want to add all of those files to your commit. Once you've added all the files that you want to make changes to in the remote repository, then you will commit the changes that you've made. When you make a commit, you have to add a commit message. Commit messages should usually be like a meaningful description of what it is that you've done. Once you've made commits, you will have to push the changes that you've made up to the remote repository. So committing to the repository is something that's happening just on your laptop. Once you've made the commits, you actually have to send the commits that you've made to the remote. You have to send them back to GitLab by pushing the changes. You can also pull changes. So when other people on your team have made changes to the code that's on the remote repository, you're going to have to pull those changes to your local laptop so that you have the changes that they've made. You're going to be doing merges and branches. Branch is a way for you to start making changes to code without affecting other people's work. And then merging a branch is what you will do after the branch is finished. So you've finished working on this thing, you want to merge it into some other branch. We're going to talk about strategies for doing branching this class. That's one of the main topics that I want to spend time with. So the stuff that you are going to have to do as a team is pick one person on your team to start the project. That person's going to have to initialize a project, create a new project, and then push that up to your remote repository on GitLab. And then everybody on your team is going to have to clone it into their own Android Studio so that you can start making changes to it. That's my hyper crash course to version control, but we'll spend more time talking about concepts in a second. Just want to hold and make sure we're all okay with this so far. Yes?
Difference between loading the project and pulling changes from the
so the question is, what's the difference between cloning and pulling? Cloning is something that you do the first time. So you're just cloning the entire project to your local machine, and then that's the last time you have to clone it. Pulling is when you want to take the remote repository and take all changes that have been made since the last time you made a pull. So clone is just the first time. I don't have this repository on my machine. I want a copy of it on my machine, so I'll clone it. And then pull is, I've got it, and I just want to get new changes from it.
Can I also know the difference between committing and pushing?
Committing and pushing. Committing is you saying, these are the changes that I've made to the project, but it's committed just to your machine. Pushing is taking the commits that you've made and sending them up to the remote server. We okay? Okay. All right. So I'd suggest that you spend a little bit of quality time with the sample project. You might want to do this as a team. You might want to do this by yourself. You might want to do both, just to get a sense of what a good structured project looks like, so that when you're starting to build up your own stuff, you can model what you're doing after something that looks like this. This project is going to be updated throughout the term. So for each iteration, I'm going to be merging changes into this that reflect the kinds of changes that you're going to have to do with your own project for each iteration. So they're always going to be a model of what you should be doing with your code throughout the term. All right. So version control. That was our little crash course to Git. That was our tiny crash course to Git. But I do want to spend a little bit of time giving you some context about what version control is, more generally than just here are all the commands that you need to run with a version control software like Git. Version control in general, when we're thinking about projects and project management and software development, is storage for things that are primarily source code. So the code that you've written for a piece of software, files that you're using to configure the source code that you're building, or example files for that, assets for your project, so things like images or 3D models, or other stuff that you might have that represents the stuff that you need for your project, and typically not compiled or binary files. When you're working with version control, you don't usually put the .class files that you get out of compiling Java files into the repository. This isn't something you care too much about. Very generally, the stuff that you will put in version control is the stuff that has been created by you by hand. The stuff that gets created by your compiler or some other tool from what you've created by hand doesn't usually go into version control. The main idea with version control is that we're not just tracking files. This isn't just Dropbox. What we're doing is tracking changes that have been made to files over time. That's the big goal, is to keep track of the changes that have been made to files over time, as opposed to just having a remote shared repository for files. And while that's not the main goal, to have this remote shared repository of files, it's a definite positive benefit in that it's going to facilitate collaboration with you and your team. You're going to be able to have a shared remote repository and be able to work from that. There's two major kinds of version control software systems. The first one is called centralized version control software, and the second one is called distributed version control software. We're going to be using Git, which is a distributed version control software. It is a kind of distributed version control software, but just so we're all on the same page, the way that we're probably going to use it is as though it is a centralized version control software. That's pretty much how we're going to be using it to accomplish the needs that we want. Centralized is the version control software that has been used since there was version control software. And in the beginning, this was, we've got a shared network drive, or we don't have a shared network drive. We use email, and we just name files with versions. So like assignment 1, version 1, assignment 1, version 2, assignment 1, version 3. I see some people kind of smirking at this. I do see some people kind of smirking at this. The worst part about this is that biologists and other scientists still do this. They're just sending emails around with Word files that are like version 1, version 2, somebody's initials, version 3. This is something that we don't do anymore, We don't do this anymore. This is something that some people still do, but this is not really what we do. A really long time ago, this was starting to share floppy disks and like literally walking around and giving people floppy disks of source code. Then there was software. At first, the centralized software version control was local only, and it was really only good for one person to use. So you'd have software that's something that you use on the command line, and it's keeping track of changes over time to the software that you're building, but it's just for you and for not really for anybody else. Eventually, we got software that was called CVS and then Subversion. CVS and Subversion are client-server model, and they start to have a centralized, like, this is the main canonical repository of software for this thing. All of the changes and the files that you've got that are part of this repository are they're just kept on a server that's stored centrally, like in an office somewhere. The version identifiers were managed by the software. So every time somebody would make a change to something, your version control software would just give you a new version number for the software that you're building. Changes are tracked. This is a good thing. We have software that is helping us keep track of the changes that we're making to software over time. But the problem with it is that it's really hard to have many people working on the same repository at the same time. We're going to look at two ways to do branching in Git today. And one of the ways that we're going to look at branching in Git is to not really use branches at all. And that's kind of using this model. And it's fine, but it's going to not be great in terms of working together collaboratively. The worst part with these centralized version control software systems is that you can't work offline. you have to be able to send work to the server, to that central server, for you to be able to keep doing work. In distributed version control software systems, the concepts and the terminology are mostly the same. So when we were thinking about a long time ago, before most of you were born, when we were thinking about centralized version control software systems, we still used words like committing and pulling changes from the remote server and pushing changes to the remote server. The main difference here is that everybody gets a copy of the entire repository's history. Everybody gets a copy of it. So it's not just located centrally on the server. Everybody that has cloned a copy of the repository has the entire repository on their system. One of the side effects of that is that with Git, you can do things like commit to your repository without having a network connection. Do all buses have Wi-Fi now? Do they all have Wi-Fi? No, okay. Do any of them have Wi-Fi anymore? Some of them do. There was like a pilot program where some buses had Wi-Fi. When I took this course, this is turning into me like old man Franklin up at the front of the room. When I took this course, back in the day when I took this course, we used Subversion, and sitting in the bus is really boring. So I'd bring my laptop and I'd code for as long as I could before I started to get like motion sickness and I had to stop. But I couldn't commit things to my repository because we were using the centralized version control approach. We were using Subversion. With Git, you could be on the bus and commit changes to your repository because you don't have to push to the remote repository at the same time. These are two separate steps now, as opposed to being one atomic operation. Branching and merging are easier in this decentralized or distributed version control software system, primarily because it is meant to be distributed. And it's meant to facilitate many people working on different things all at the same time. For the record, Git as a distributed version control software system was created by Linus Torvalds, who is the author of the Linux kernel, for use in the Linux kernel, to do version control for the Linux kernel. They had been using something before, I don't remember what it's called. It doesn't really matter that much, but it's created for a massively distributed group of people to build big software. So here's the typical workflow, and this is the workflow that we went through. We start by cloning or initializing the repository. You've all initialized a repository. You didn't do this on the command line, but you did this on the web interface. You might have done this in the command line, but you've all initialized a repository at this point. The other approach is to clone an existing repository. After you've got that repository on your local system, then make a branch, start making commits to that branch. Pull the changes that you get from the remote server. So you keep working on something, you've got this feature, you've got this user story that you want to do, you're working on it in your own branch. You pull changes because you've got other people in your team that are making changes to their own user stories and features. You pull the changes from the remote server onto your local copy to get the most recent changes, and then you will merge those into yours. If two people have been working on the same file, you're going to have conflicts. So if you're trying to make changes to the same file, so you've made changes to something, you're working on a common user story that uses the same data model classes, and you're both making changes to it, there are going to be conflicts that will happen. And it's your job now to figure out how to take those conflicts and make it into a compilable class again. Once you've done that, push the changes you've made to the remote repository, and then just go back to 2 and start all over again. So pick up another user story and just start hacking and keep going with that. With version control, there are different kinds of strategies that you can use for branching, and there's different kinds of strategies that you can use for doing branching on a team of people. The two that I want to bring to your attention are GitHub Flow and trunk-based development. And I want to try and visualize these. The articles that are describing them are fine. They're fine, they're good, they're very text-heavy. So I'd like to just draw out the general flow of what this looks like. So let me pop this open. The typical way to think about what version control looks like is as a graph, a directed acyclic graph. With version control, with Git, we have branches. A good name for your branch that is common to everybody, the branch that you want to be releasable at any given time, is main. This is a good name for that branch. This branch has historically been called master, but main is just a better name for it. It's a more descriptive name for what it actually is and what it actually means. So let's use this terminology to describe that. The very first thing that you're going to have in your repository is the commit that you made to initialize your repository, your initial commit. You've got 5 people on your team. Everybody's going to clone at this point. So everybody's going to make a clone on their own machine. Everybody will get a copy of the repository in this state. So somebody has made the initial Android Studio project. They've committed it and pushed it to the repository. Everybody's going to clone that copy of the repository. With GitHub Flow, I'm going to draw this just kind of in one long line, but you're all going to have copies of this repository. With GitHub Flow, the strategy here is that you're each going to be working on a feature. I'm going to be using user stories. This is the terminology that we're using to describe the unit of work that you as individual people are going to be doing. So I'm going to say user story number 1, number 2, and number 3. So let's say we've got 3 people on our team. We've got 3 user stories that are being worked on concurrently. The strategy with GitHub Flow is that starting from this, you would have 3 branches. So in the Android Studio UI, on that really big, long, tall menu that was for version control for Git, there's this option to do a branch, to create a new branch. With GitHub Flow, the strategy is that each person that's individually working on a task will make this branch. So this is going to be branch number 1 for user story number 1. This is going to be branch number 2 for user story number 2. This is going to be branch number 3 for user story number 3. So each user story is going to get a branch. As this is happening, you're going to be working on stuff. You're going to make commits. So you're going to start building the UI. I'm finished with the UI, so I'm going to make a commit. You're going to start building the data model. I've finished the data model. I'm going to make a commit here. You're going to do testing. And at this point, you're going to say, hey, I'm finished with this. I'm finished with this feature. I think that this user story is ready to be merged back into the main branch of this project. So I'm going to pop these over to the side. They're all going to look very similar to this, so I'm just going to kind of leave them here, dangling off to the side. With this GitHub Flow strategy, what you're going to be doing here is creating a merge request. This is something that doesn't happen in Android Studio. So you've got this branch, you push your branch to the remote. You push all the commits that you've made in this branch to the remote, and you make a request in the system to merge that feature into the main. So create a merge request to merge into main. Once you create this merge request, the idea is somebody else on your team will review your changes. They're going to read the code that you've written, and they're going to make comments on it. They're going to be looking for things like, have you commented your code? They're going to be looking for things like, have you tested everything? Are there parts of this code that you haven't written tests for? They're going to be looking for things like, does the UI make any sense? Like, do you just have buttons all over the place and you haven't actually built something that looks reasonable for what you're trying to build? They're going to be looking for things like, do they understand your code? Because if they don't understand your code, then you kind of have to fix it and change it to make it so that they can understand your code. You're going to make this merge request. There are going to be comments from this other person. You're going to make another commit with 2 S's instead of like 5 in the branch that you've got here. And then eventually what's going to happen is the person that's reviewing your code is going to say, okay, this looks great. Looks good. And then the merge happens. There's a button in GitLab that you can click. And you're going to get all of the stuff that you've done in this feature branch, in this long-running feature branch, merged back into your main branch. The idea with this is that main is always in a releasable state. So if I were to clone the latest copy of your repository at any time and switch to the main branch, there's not work in progress. It just is complete for the things that are complete. The stuff that is incomplete or work in progress lives in these feature branches, these long-running feature branches. The merge request part, this is kind of up to your team to decide if you want to do this. I would strongly recommend you do it. I would really recommend you do it. It will slow you down. Don't get me wrong. It takes time. You have to take time out of your own coding to review somebody else's code. It takes time, it slows you down, but it results in a better product, and it results in more people on your team knowing about different parts of the application. It's going to spread knowledge around a little bit more. Numbers 1 and 2 there. So I'm going to extend this a little bit. I'm going to go with number 2. Let's say number 2 is still happening. At this point, what number 2 should do is it should also merge stuff from main into it. So it should pull the changes that have been made from main into number 2. And then only after that should it make a merge request into the main branch again. Big strategy, have long-running features for the users, long-running branches, for the features and user stories that you're building. The main branch is always releasable. There's not incomplete work in the main branch. Everything that's in the main branch is always complete at any given point in time. Is that good? We're okay? Any questions? Okay. There's 2 ways to do trunk-based. One is that you have a main branch. And then you just start committing to the main branch and pushing to the main branch. Don't use branches. That's one approach to using this strategy. So what you'd have here is something like WIP, work in progress, number 1, commit, push. WIP number 2, commit, work in progress. And it's a little bit chaotic, but it is a way to do it. The problem with this, obviously, is that you are going to have to be constantly pulling from the remote repository because people are constantly pushing to the remote repository. That's fine. The other problem with this is that your main branch is not always in a releasable state. So you will just, by default, have stuff in there that is going to cause problems. The other way to do trunk-based, and this is described in the article, is to do something that looks a little bit like what GitHub Flow is doing. So having these feature branches, but there's a much shorter kind of turnaround. You're not necessarily completing an entire feature in that branch. You're just doing parts of a feature. Again, my issue with this is that you have work in progress in your main branch sometimes, which is not ideal, not really what you want. Okay, so I'm going to leave this up on the side. I'm going to put this to the side. Branching strategies. I might make this bigger. We've talked about 2. There's a bunch. I had to cut articles from what I'm asking you to read because I don't want you to read too much. There's just so many different kinds of ways of doing branching strategies. But it all boils down to this. The way that I do it is good, and the way that you do it is bad, and you should feel bad. Yeah. I'd like you to discuss this with your team. You probably haven't started coding over the weekend, so start thinking about what your approach is going to be to doing branching. I'm going to suggest that you also make a decision at this point as to what strategy you're going to use to assign issues to people. Are you going to be breaking up your team based on layers, or are you going to be breaking your team up based on user stories? This is your opportunity to try something. This is a class. Yes, you know, there are grades attached to projects, but the fallout here is that you don't get fired. I also want to remind you again, and I will remind you of this frequently throughout the course, the score that you get on projects is not related to quantity. It is not related to quantity. Yes, there are minimum quantities that you must meet, but we are looking primarily for quality. You have an opportunity here to try out different things. I would suggest that you try out different things and reflect on how that experience has been like. So decide what kind of branching strategy you want to use and decide how you're going to be assigning tasks to your teammates. And I will give you about 10 minutes to do that. Okay. So I'd like us all to come back together here for a second. So this is a suggestion that I just made to a team that I want to share with everyone. These are 2 models that I've shown you. If you don't have any experience with version control, you don't have any experience and you just want something that works, please just adopt one of these things. Pick one and go with it. But there's also nothing wrong with doing something like modifying that existing approach. So the suggestion that I made to this team was because they've made the decision to do layer-based work distribution to their teammates. I got no idea what's going on. I'm pretty sure that's next door and not like coming out of my laptop. Yeah. It sounds like they're watching a Western movie over there. So the strategy with GitHub Flow is that you've got a main branch. So I'm just going to draw like tiny circles now. I'm not going to do much more than that. You've got a feature branch for a user story that's going to start working on stuff. The suggestion that I made to this team was, if you're going to do layer-based, one approach would be to have multiple branches off of your branch. Multiple branches off of your branch. One branch for the UI. So this is the UI branch for this one. Another branch for your data model. Another branch for something else, so the persistence layer. And this is kind of complex. I fully acknowledge that, and I fully admit it. But the benefit that I'm getting out of this is that you have somebody on your team that's really confident building UI stuff. They know what to do. They know how to do it. You can make merge requests back to your feature branch here. And this is an opportunity for the person who is feeling very confident about UI stuff to share with somebody else on the team. I want you, who doesn't have any experience with UI, to review this. This is what I think is good. Please tell me what you think. It gives that person an opportunity to see code related to UI stuff. It gives that person an opportunity to maybe see the rationale why decisions are being made about how the UI is being constructed. The benefit of this modified approach to me is that you still can share knowledge with other people on your team through merge requests like this. There's a lot of moving parts here. There are a lot of moving parts here. It's complicated. Again, I fully acknowledge that it's complicated, but it may be worth the payoff because you're not going to have main in a state where it's got work in progress. You've got this other feature branch that's long running where you're making changes off of that as opposed to doing everything in the main branch. If you do something like this, so you start working with GitHub Flow and you decide that it doesn't work for you, or you want to try doing something different, please document these decisions that you as a team are making. Add a section to your README file. You've got your vision in it right now, but add a new section, add a new subsection that is decisions that you're making. And document why you have this crazy branching strategy so that when I look at your code, or when the grader is looking at your code in your repository, we understand why you have this crazy branching strategy. That's my suggestion. Whoops. There is no correct workflow. There's no best workflow. There isn't even a best workflow. There's a best workflow for you and your team. There is a best workflow for you and your team with the knowledge that you have right now. And there's a different best workflow for you and your team 6 weeks from now because you have more experience doing this stuff than you do right now. My advice to you is to pick one. So pick something right now, try it for a while, see if you like the review part of code review. If it isn't working for you, or if it is working for you, keep what is working and throw out what's bad. Code reviews are not helping us spread information around. They're just slowing us down. Stop doing code reviews. I don't think that's going to be the case, but maybe you will find that. Maybe you will all turn out to be very excellent Android developers, and you don't need to share that information. It just... I gotta know. So on the screen right now is this picture of like a Shakespearean era guy, and it's PowerPoint, and it says Edmund Spencer. I don't know who Edmund Spencer is, but it doesn't sound like an engineering course. Okay. So let's switch topics entirely. What I'd like you to do with your team right now is to have a discussion. You were introduced to testing in Comp 2160. That's the very first course where you had to do any kind of testing, where you should have done testing, where you should have done testing for the first time. You may have done testing in Comp 2150, depending on who your instructor for that course was. You may have done JUnit, you may not have done JUnit. And now we're here. The last time you saw this was in second year, and now we're back to looking at testing in third year. In 2160, you were told a little bit about the idea of unit testing. You might have been told about the idea of black box versus white box testing. You might have been told about test scaffolding. There might have been keywords that were thrown at you that may or may not have stuck. In 2150, again, it's not really a formal outcome of the course to do testing, but you may have done it anyway. I want you to discuss with your team, why are we doing testing? Why test? Talk about this with your team and then answer here on Mentimeter. Just do one device per group, but you can answer multiple times. So if you have multiple reasons, give me one and then answer again. So talk, just talk. Don't do Mentimeter yet. Just talk for 5 minutes. Why are we doing testing? And then start submitting here. All right. So to make sure things work, I think that's a good reason to do testing. Save time in the future. So I'm interpreting that to say that we have to do less debugging in the future if we do testing now. I think that's a good reason to do testing. To make sure things work and to make sure that the code meets the requirements, I think that these are together. I think these are the same kind of goal at the end. We want to make sure things that work. We want to make sure things work. And we want to make sure things work the way that we said they were going to work. Those are two different things. To make sure something works is to make sure it doesn't crash. I don't want to get a null pointer exception when this code runs. To make sure it does what it says it's going to do and it works the way it's supposed to work is to actually verify that the code is doing correctly what you said it was going to do in the first place. To avoid surprises during production, I like this one. When I was a co-op student, I worked at the National Microbiology Lab at the NML. And yeah, I didn't do testing. And I would deploy stuff. So I was working on a web application there. I would deploy stuff. And then every time I would deploy something, it would be like, I'm gonna deploy it at 3 o'clock in the afternoon and then go home. And I would dread coming to work in the morning because my phone would inevitably have the voicemail light flashing on it because something was wrong. So to avoid surprises during production, I like that. Yes, if I could tell myself 15 years ago to do testing, then I would have avoided surprises during release of my code, and I wouldn't have to dread going to work in the morning. To ensure our code is rigid and rigorous. Rigorous, I think, is the right word. Rigid is maybe less the right word. Rigid means to me like we can't make changes to it very easily, and I don't want that, but I do want it to be rigorous. I want it, again, to do what it says it's supposed to do on the box. Fundamental to software engineering principles. I like that. Yeah, it's a good practice to do it. I like it because it is a good practice to do it, but I'm going to say that we shouldn't just do it because we do it. We should do it because it provides value to us and to our clients. We should do it because it's actually useful for us to do. To make sure all possible cases work without any issues. So when I was a co-op student, I also worked at IBM as a contractor at Agriculture and Agri-Food Canada. I think I said that before in the first class or two. And I had this ill-conceived idea that I was doing testing and I should test everything. I should test every possible case exhaustively. That was a bad idea. To do everything, to try and exhaustively test everything was, I don't know, it was like going down a rabbit hole. And I was thankfully pulled out by the team lead. Stop doing that. You don't need to test that many different things. But to make sure certain cases work, An unambiguous and objective way to find if a code works? Yes, it's definitely unambiguous and objective. This is literally code running your code. There are testers in industry. There are people who will run your code and evaluate it. There are testers that are living people and are, they're able to have faults like other living people. Testing edge cases, defensive programming to make Rashid proud. Okay, ask you to do tests in the first case, but making sure that somebody else's code does not mess with how your code works, making sure that the code that you've written and how it has changed still meets the requirements that you said that you were going to have. All right, I want to be respectful of your time, so I'm going to move over here. We're going to talk about testing on Thursday's class. Please take the time to get your Android Studio project started and cloned on everyone's machines. If you're having problems, please come talk to me as soon as you can. Bye, everybody.